Hi guys. Um, Once again, my name is Adiola Adeshino and co-founder of Young Pharmacists in AI Africa. Welcome to the February workbook for the machine learning program for pharmacists. Right in this part of the program, we are going to be looking at regression, which is a type of supervised learning in machine learning. In March, we'll be looking at classification, and then in April, we'll be doing clustering. Right. So in this month, you're going to be helping the retail company estimate the optimal prices of their houses using different parameters. And then here are some basic information about the schedule for this month. On the night of February 14th and 24th, we're going to be having mentorship sessions that are very, very important. So please take notes. And then once again, the instructions are very clear. You need to copy the code that you get in this workbook into your Jupyter notebook, arrange the notebooks in the same order, and then upload them to GitHub. If you have issues with GitHub or any of the required packages, please refer to either the WhatsApp groups or send me a message on Slack. So very quickly, I'll just explain a few things. So in module one of this workbook, you're going to be going into exploratory analysis. And really, exploratory analysis is the first thing that you should do in machine learning because it gives you basic intuition about your data. The first thing you should do is you should know a few things about your data. So this tells you the data shape. df.shape tells you that we have 1,803 instances, and then you have 26 features to work with. dtypes also tells you whether your feature is an integer, it's a float, or it's an object. If it's an integer or float, then it's of course a numerical variable. If it's an object, then it's a categorical variable, right? So you need to understand the distribution of your numeric features. So this is what an histogram plot of numeric feature does for you. It just tells you the frequency of every member of your numeric feature, and then it gives you an idea of outliers, right? So this, for example, this part of the numeric feature could be considered to be an outlier, so you know what to do with it. Then you can summarize numerical features to give you some statistical understanding, like count. Count here tells you that the basement feature has some null values, has some missing features, so you need to replace them. So you can know the mean, the standard deviations, minimum, maximum, and all of the percentile information that you need to know. You also need to understand the distribution of your categorical features, right? For example, this tells you the count of your categorical features, and this tells you that there are missing values, right? Unique tells you how many unique variables are in that categorical feature. Top tells you the top count and then the frequency of the top count. So these are things that you need to know about your data set. Segmentation is the relationship between the categorical feature and the numeric features. These are very important. If you have 100 variables, for example, then you need to know the relationship between all of those features, how they relate to the target variable, which is what you are trying to predict. Like correlations too are very, very important. You need to understand how each of your data sets correlates with your target variable. These are very important. In module two, we go into data cleaning. As data scientists, if you have if you have 10 minutes, if you have 10 hours to do data science, you are going to use 8 hours out of 10 hours to do data cleaning. So it's very important because real life data is very messy, right? So you need to know how to drop unwanted observations. You look at that later. uh, in machine learning, you find out that some features are unwanted. There are things that don't relate to your target variable, so you want to drop them. If you don't drop them, they are going to overfit your model. The next thing you need to do is to fix structural errors. For example, in the basement feature, there are non-values, so you need to replace the non-values. And then sometimes there are very, very sparse classes that would make your model underfit. For example, there's composition in small letter and composition in capital letter. So you need to adjust all of that. You need to remove unwanted outliers in your data set. There will always be outliers, right? So here you will learn how to use a violin plot to remove outliers. Then you need to learn how to label missing categorical data. So you check for null values and you replace them. Most times in machine learning, you replace null values with zero, and sometimes you need to replace them with a mean of the entire categorical variable. And then here you learn how to replace missing numeric data. So that's all for data cleaning. In feature engineering, feature engineering is the mainstay of the work in machine learning, which is why we cry out for domain knowledge. We cry out for people who have domain knowledge in fields where they want to apply machine learning, and which is one of the reasons why we are doing what we are doing, right? So you start with domain knowledge, you create interaction features. Interaction features has to do with creating a feature from two different features, right? You can group sparse classes. There are some classes that are very sparse. You can group them into the same class just for some added advantage. Then you can encode domain variables as well. So domain variables, because your machine learning algorithm cannot handle categorical data directly. So you need to create a new data frame to turn them from words into numbers, right? So your machine cannot really identify words, but it can identify numbers. And then you remove redundant features. For example, you want to remove the year, tx underscore year and year underscore build feature because you think they are not really important. So and that's that. Um, Next thing is going into the regression algorithms, right? So we've explained 5 regression algorithms here, and really we want to explain the basic intuitions for regression algorithm. You know all of the y equals to mx plus c, which is the formula for your basic linear regression. Your y is the dependent variable, x is the independent variable. This is a mistake, and then C and the M is your constant or your coefficient. For multiple linear regression, this is how it goes: M1 plus X1 plus M2. This is where you have about 5, 10 different features, right? But linear regression is flawed. Why is it flawed? Because one, it is prone to overfit with many input features, and two, it cannot easily express non-linear relationship. You find out that in real life data is non-linear. It goes in zigzag manner, and then linear regression would be a very bad way to treat such data. But we use linear regression to explain machine learning to beginners because it's what you understand is what you're familiar with. So in this course, we have about uh, 5 different machine learning algorithms that employ linear regressions but have been tweaked. So we have regularization in machine learning, which we use to combat the first issue, the issue of being prone to overfit with many input features. So for that, we have lasso regression, we have ridge regression, and we have elastic net. Lasso regression, what it does is that it penalizes those those coefficients, the M and your C, which is what your machine is actually learning. So it brings it down to zero, and when it does that, it takes out some features that are really not important. Ridge regression doesn't bring your coefficient to zero, but it forces them down to the minute to a very small amount, right? And then elastic net is a mix of both absolute and square size, right? And then decision tree is what we use to combat the second issue that says it cannot easily express non-linear relationship. So we use the decision tree in this machine learning course to express non-linear relationship. And then we have 2 decision tree algorithms. We have random forest and boosted trees. You really do not need to know the mathematics behind all of this right now, but in our 3 days master class, we'll take you through all of the mathematics. All you need to do right now is copy the code, paste it in your Jupyter notebook, and make sure it works, right? And then at the end of the month, we are going to have a Kaggle competition, right, where you would use all of the things in this workbook. You would then use them on new data sets, and you use them for newer predictions. The last part of this is model training, and we are going to be doing lots of explanations. I'm bringing Rising Odegba to explain model training later in the month. So until then, if you have any questions, reach out to me on Slack, reach out to me on WhatsApp. If you're not on the WhatsApp group yet, please make sure that you find your group because you are going to be attacking the regression problem together, right? You're going to be attacking regression problems together. So thank you very much. God bless you.